All right. On line segment CD, you are given the endpoints. Find the midpoint and the distance. Okay? So to find the midpoint, all right, we always use a certain formula. Can anybody tell me what the formula looks like? X1 plus X2, yep. Yep, divided by 2. Y1 plus Y2 divided by 2. All right, so looking at our endpoints, we have the first endpoint we'll call X1, Y1, and the second endpoint we will call X2, Y2. All right, so when we plug in, what are my two X's that I'll plug in? -4 and 3, so -4 plus 3. And then what are the two Y's I'll plug in? -5, -6. So -5 plus -6. All right, so from here we simplify. What is -4 plus 3? -1. -1 over 2, can that be reduced? No, so the answer is -1/2. You could also have the negative on the outside of the fraction, doesn't matter. All right, and then what's -5 minus 6? -11. Can that be reduced? No, so do I want your answer to look like a fraction or a decimal? Fraction. So boom, that's your answer to find the midpoint. Questions on that one? Okay, I'm going to shrink it, and then we're going to find the distance. I just made it super small. So if you have a question about it, it's over there. All right, we're going to find the distance. The distance formula looks similar to this. What did I say you put in the first part of the parentheses? Yeah, subtraction, and x1 minus x2. And then you'll have y1 minus y2. Notice how I colored it. Can anybody guess why I colored it this way? My x's and my y's. We know which one's which, but yeah, we look at it, it makes an ordered pair. Look at the orange, they're in the front of the parentheses. X1, Y1, which are over here. I'll re-highlight. X1, Y1, you should be able to read it in the front of the parentheses, and it should read -4, -5. The same thing with the X2, Y2. All right, those should be the second coordinate. All right, so let's plug in our points. What is my X1? -4. And what is my X2? 3. All right, what is my Y1? -5. And then my Y2? -6. So again, you should be able to look at this and read your coordinate points. Is -4, -5 a coordinate point? Yes, it is. It's letter C. Is 3, -6 a coordinate point? Yes, it is. So I have them plugged in correctly. So from here, I just do my math. What is -4 minus 3? -7. And then -5 minus -6, the double negative makes a positive. So what's -5 plus 6? Just 1. Yep. All right, common mistake here. What's -7 squared?
-49.
Positive 49. Remember that -7 squared is the same thing as -7 times -7, which makes a positive 49. Okay? All right, and then what's 1 squared? 1. All right, we add 49 plus 1 is? 50. Then what do? Upside down division, y? To simplify it. What's the smallest number to go into 50? 2, and it goes in? Smallest number to go into 25? 5, and it goes in? 5. So the two pairs, do they stay under the radical or come out? They come out, so 5. And then what stays under? 2. Ta-da! So our distance is 5 square root of 2. Okay? Questions on these? Okay, go ahead and go to your notes. We're going to talk about 1.4 perimeter and area in the coordinate plane. So here's what I will tell you students struggle with the most about this section. Because I have graded half of the test now. And the part that students dunk up most, do you remember where it said plot these 2 points, or plot these 2 lines, see if they're congruent? Remember that? So a significant amount of people didn't plot the points correctly, so that made their answer wrong. Okay, so here we're going to talk about how to plot points. What is the perimeter of an object?
Inside.
The outside. So in this room, what would the perimeter technically be?
The walls.
The walls. What would the area technically be?
The carpet.
The carpet. Okay, you could even say
Ceiling.
technically the ceiling. All right, so we're going to talk about them in the coordinate plane. First, we need to talk about some words. So here's what I want you to understand. Do you see this big old blank? That's full of the term and the vocabulary, like the definition. So I'm going to tell you the part to underline or to write down. Okay? So when you see it, don't get freaked out because it's a long definition, but I'm going to show you the part I want you to underline or want you to write down, sorry. So a polygon is a plane figure. I don't want you to write down that. I do want you to write down it is formed by 3 or more segments called sides. Okay, it's a shape formed by 3 or more segments. We call them the sides. And then each side intersects exactly with 2 other sides. Now I will explain what that means. I've drawn 2 examples here in my little thought bubble. So the first one, we're going to decide whether or not it is a polygon. Okay, so polygons have to be formed by 3 or more segments. Are there 3 or more segments? Yes, there's 1, 2, 3. Each side intersects exactly at 2 other sides. So let's look at this side right here. I'll even highlight in a different color. It intersects with how many other sides? It intersects with 1. It only intersects with this side. It needs to intersect with 2 sides. Exactly 2 sides. So looking at the other one, this blue one, okay, this side here intersects with the top and the bottom. Okay? So really only closed figures count as polygons. That's what that means. Okay? So that's what you just wrote down. Polygon is another word, again, for a shape in geometry. So you've learned a lot of them already, just being a person in this world. You don't have to write down all this, just pause. Sides, the only thing I want you to write down is that they are segments. The sides of a polygon are segments. Now, what does a segment look like?
2 dots.
2 dots in what? A line. Is this line a curved line? It is not. Sorry, it bothers me. It's not a sorry, that just is what it is. It's not a curved line, it's a straight line. So is a circle a polygon? Why not?
Because it doesn't have no beginning.
Doesn't have segments? And it's curved. Okay? So if you ever see an object that could look like, oops, sorry, that's ugly. It's not pretty, but if you ever saw an object like this, okay? It's a what? A lock, yeah. Okay, so it's not a polygon because of this curved. That's not a line segment. Okay? The bottom isn't either. Like, I just meant like together. Like this would be considered a polygon. Sorry, it wasn't a great picture. Because these are line segments, whereas before it was a big arc.
Okay. Nope.
So the other one before was, this is a curve. You look like a piece of bread. Is what it is. I'm just kidding. Justin's a great person.
What does that have to do with his head shaped like a bread?
I didn't see. Do you see the difference between the two? The left is formed by line segments, and the right is formed by a big curve. Okay? I'm offended for you, buddy. Vertices, vertex, sorry, vertices is the plural, so don't. It's the endpoint of a side. So I will again show you what I mean. I drew this perfect triangle. Oh my goodness. Have you seen anything prettier?
Who is it?
Just kidding.
No.
So vertices, and that's the plural. So a vertex are where the two corners come together, or two sides. So these are called vertices. Vertex in plural form. So all these dark green, those are called the vertexes. Vertices. Okay, we have one word left to learn. How many of you wear contacts? 1. Cool. 2. I'm the third. All right, so whenever you learn how to wear, do you wear one? No? You just raised your hand. Oh, no. So whenever you get contacts, they tell you to keep it concave, right? They tell you the difference between concave and convex because concave, you put it in your eye, and your eye feels great. Like, you don't even feel your contacts. You put it in convex, and, like, the ends of your contact, like, flip outward, and it hurts a lot when it's in your eye. Okay, so anyways, so you're going to learn about convex and concave. Concave is the opposite of convex. Really, we only talk about convex. A convex, you're just going to have to write all of this, I'm sorry, is a polygon is convex if no line that contains a side of the polygon contains a point in the interior of the polygon. I will literally explain what this means. Just write it down. I'll give you an example. My beautiful art skills. I'm not very funny, so I don't know.
No, I was being serious.
Oh, you?
I was serious. I don't know
I'm not a very funny person.
the dry
Funny looking at times. What?
The dry humor is what people want nowadays.
Yeah. By the end of the year, the dry humor is what makes people think I don't like them. But just putting a disclaimer, I like all of you. It's only the third week of school.
Exactly.
I like all of you. So there's that.
That means that she can not like.
No, that just means I haven't had my limit of some of you. You know what I mean?
That's exactly.
You know what I mean? After 180 days, you're like, yeah, you can go to the next class. Some people.
Like, I'm going to get out.
All right, so I will explain what convex means. For concave, I want you to think of something that caves in. Have any of you ever built a fort? I pray that should be like a requirement of all childhoods.
Oh, yeah.
Mackenzie has recently, apparently. Has anybody else built a fort? Where you put up?
I
Okay,
literally
good.
sit back and supervise with my kid. You guys stay up.
Oh my gosh,
When I was a
that's
kid,
sad.
yeah, I mean,
I don't still build forts. I've done it. So whenever you build a fort, it's not Fort Knox. It's not made of wood. It's probably made of your blankets, right? Okay, so at some point they cave in, right? So they come in towards you, the ground or whatever. So whenever you think of concave, you want to think of those blankets caving in on you. And I'll explain what concave versus convex means. So in this object, it is a rectangle. All of you can see. So let's look at, this is the center of it. Okay, we all agree it looks like the center, give or take. So what this convex means, okay? Convex means the side doesn't come in towards the center. Do you see what I mean? So the green that I just drew, that would be coming in towards the center. That would be concave. But what's there right now, none of these points come towards the center, right? They stay a good amount of distance away. None of them go back in towards that center. So that would make this convex. Concave would look like the star I've drawn. The center, give or take, is like here, okay? So this point is pretty far out from the center, and then it goes in towards the center, and back out, and back in towards the center. So that's where that interior of the polygon comes in. When it comes towards the center, that makes it concave. Okay, and the more that you see it, the more that it will make sense to you. Okay? Before we get to the section where we decide whether it's concave or convex, we need to learn the names of polygons. You have heard some of them, I pray. Polygons are named by the number of sides they have. What kind of polygon has 3 sides, y'all? Triangle. Look at that. You will need to know the numbers 3 through 12. Okay, 3 through 12. 3 through 12. After that, I'll show you how to name it. Okay? 4 sides. Most class get this wrong.
Rectangle.
Quadrilateral.
Rectangle. Square.
Quadrilateral.
I said that.
That's why.
Did you?
I meant to say that.
Quadrilateral. So here's what this means. Okay, you're not wrong. A rectangle has 4 sides. A square has 4 sides. So think about this. He died, but I had a poodle. Okay? A poodle. Alright, a poodle. His name is Java. A poodle. And a poodle is a kind of what? A dog. Are all dogs poodles?
No.
No. Are all poodles dogs?
No.
Wait.
Are all poodles dogs?
Yes.
Oh, yeah.
Yes, they are. Yes, they are.
About it.
So think about this. Not all quadrilaterals are squares, because a square is a type of quadrilateral, just like a poodle is a type of dog. That makes sense? So like the big Papa name is quadrilateral, and then it has specifics that it can be. It can be a square, it can be a rectangle, but we call them quadrilaterals. Okay? It's a patriarch like Abraham. See, I talked to my last class, and I said, you're learning about patriarchs in history, and they were like, what?
Yeah.
Yeah, you are. Abraham. Yeah. Anyways.
Yes.
5-sided. Pentagon. Why do we know that's a pentagon? Penta means 5. What else in the world is a pentagon?
Washington.
Yeah, Washington Pentagon, the government building we have. 6.
Hexagon.
That's 8.
It's a hexagon.
I knew that.
It's okay. It's all right, Justin. We all make mistakes. Everybody makes mistakes. 7. You're close. It's a heptagon. It's just an H.
I said that.
I know you did. Well, she said sept, and then you said. In other things, you use sept. I don't remember what you use it for, but you're in the right track. But here we call it heptagon.
September.
8, Justin. Octagon. What in this life is an octagon? Okay, stop sign. UFC.
That's what they fight in.
Yeah. 9. UFC. Yeah. 9 sides. Nonagon.
You did.
Boom. Okay, so think about this. 10. Listen. No, listen. How long is 10 years?
Century.
A decade.
Oh,
So it's
I
decagon.
don't know why it says.
Decade, decagon.
Wait.
I will show you number 11. I don't know why your book doesn't show it to you. I will. I'll put it at the bottom here. So it's going to skip to 12 because this is from your book. 12. So here's what happens from 10 and beyond. Okay, deca means 10. Okay? So what will happen is it'll have like a prefix that means 2, and then it'll say decagon. Okay? So for 13, it is tri, and then decagon. And everything after is, does that make sense?
Yeah.
So 15 is penta, decagon. Hexa, decagon. That makes sense? So I'm only requiring you to know through 12. What is the number 2 in Spanish? Okay, so this is do decagon. Okay, so it's close, but you see that deca means 10. Anyone that is beyond 12. Okay, even though 13 is tridecagon, I told you it's fine. 14 is tetradecagon, for those of you who want to know. Anything beyond, you would say the number and then gone. So 24 sides, though it does have a real name, some ridiculous name, we would call it 24 gone. 36 gone. 54 gone.
So
Does
original.
that make sense? So they have actual names. If you Google them, there is a name for that polygon. But in this class, we would be learning 96 of them, and we're not about that. Okay, so after 12, you can put that number and gone. After 96, what shape do you think it looks like? A circle, yeah. So the more sides you have, the more it becomes a circular object. Yeah. So 11, there are two names. I prefer hen decagon. Okay, so you want to write that down? Hen decagon.
And no?
Hen, yeah, it's also an undecagon, but we call it hen decagon. In the math world, which you are currently in because you're in my class. Alright, all this is going to say is you can also name a polygon using the term n-gon, but if it's on this chart, you need to name it by this chart. Okay? So if you see a six-sided figure, you need to call it a hexagon, not a sixgon. Okay? No joke, people put it. Alright, so the example is at the bottom of your page. We have to classify it and then tell if it's convex or concave. Okay, so let's look at this. The first one, letter A, 1. So here's how you count. You can count the sides, which kind of gets confusing. I count the vertices. So 1, 2, 3. Sorry, I had a burp. 4. Oops, it's on recording. So 4 sides, which makes it a quadrilateral. Quadrilateral. So quadrilateral. Now, convex means all of the points are away from the center. Concave means some of them come towards the center. So which one do we think?
Concave.
Concave. I agree. Concave because of this point right here and this point right here. They come towards the center instead of away from the center. If it looked like a diamond instead, like it went out, that would be convex. Okay? But it doesn't, so it's concave. Letter B, we have 1 side, 2 sides, 3 sides, 4 sides, 5, 6, which makes it hexa. And it is convex. All of the points are away from the center. They don't come back in towards the center. I don't know. 'Cause it is what it is. So the next one we got 1, 2, 3, 4, 5, which makes it pentagon. Pentagon, and it is concave. I agree. So if you see these on your test or quiz, these are like Mrs. Marshall decided to be super nice to you and she gave you these. So make sure you get them correct. Okay? So if you see them, if you see more than one of them, that's me being like, here's a gift to you. Take the gift. You don't understand gifts? So sorry, buddy. All right, number 2. We got 1, 2, 3, 4, 5, 6, 7 sides, which makes it heptagon. Is it concave or convex?
Convex.
Agreed. All right, so here is the last portion of today's class. This is where the actual coordinate plane will come into play. Here's what I want you to know. Flip to the next page. To find the perimeter of any object, what do we do? Nope. There's no formula. Well, there is a formula. Pause. You add all of the sides. Write it down. Add all of the sides. There are technical formulas to it. I'm not requiring you to memorize the formula because it's so easy to find the perimeter. To find the perimeter, you add the sides. It does not matter what shape it is. You will always add the sides to find the perimeter of an object. Okay? So here's the second part. We're going to find the area. These area formulas you would know. You do not have to write down the perimeter formulas. They're going to pop up. But you do not have to write them down because how do you find the perimeter?
You
add all of the sides. All right? So, on a square, there is a technical perimeter formula. Ignore it. Okay? You add all the sides. Area formula is sides squared. You do want to write that down. Just to refresh your memory, because you should know this. Area is sides squared. Of a rectangle, it is length times width. Length times width. And a triangle. This one is literally the hardest for students. That's a right triangle. 1/2 base times the height. That's Pythagorean theorem. 1/2 the base times the height. Okay, and we're going to talk about all of these. We're going to do example 2. Again, you did not have to write down the perimeter formulas because you find the perimeter by adding all the sides. Praise the Lord. All right, so let's go to number 2. What do we need to do first to solve this, you think?
Well,
Plot the points, but in order to plot the points, we need
The coordinates.
the x and y axis, y'all.
Yes.
So, step 1, we need x. Ooh, that's not light enough. We need the x and y axis. Step 2, yes, we're going to plot the points. All right, so I'm going to color code these points. So A is negative 2, 3. So over. So remember, you go x, which is left or right, and then you do y, which is up or down. So negative 2 is my x, so will I go left 2 or right 2? Left 1, 2. And then positive 3, is that up or down? Up, 1, 2, 3. So this should be A. I'm telling you, where kids struggle the most on their test was plotting the points. Okay, so make sure you focus on that. B is 3, negative 3. So 3 is the first. That's my left or right. Which way are we going to go?
Right.
To the right 3, and then negative 3 means down 3. All right, and then C is negative 2, negative 3. So to the left, 1, 2, down 1, 2, 3. Okay, then you connect the dots. All right. So whenever you're finding the perimeter, what do we need to know to find all the perimeters?
The length of the sides.
We need to find the length of the sides.
Was that right?
Yeah. Okay, so some of these, yeah, you just literally look at it and you count. So AC is from here to here. So count the boxes. How many boxes are there between? From A to C? 6 boxes. So AC is 6. CB, 5. What's the difference about AB than the other two?
It's slanted.
It's slanted. So here's what you need to know. When it's diagonal like that, you cannot just count. But there is a way to find the, watch my word here, the distance between the two of these. So how do we find the distance between the two? Yeah, so whenever you have a diagonal and you need to find the length of it, you need to use the distance formula. So again, whenever you have a diagonal and you're finding the distance of it, the length of it, you need to use the distance formula. All right, so we're going to use our distance formula, but what 2 points does this line involve?
A and B.
A and B. So does C have anything to do with my distance formula right now? No. Make sure you use the correct 2 points. All right, so my distance formula, remember, always is x1 minus x2 and y1 minus y2. All right, so what would my x1 be? Yeah, my x1 is negative 2. All right, what is my x2? 3. Oops, sorry. My x2 is the number 3. All right, and then my y1 is this positive 3. And then my y2 is negative 3. So again, you should be able to read your coordinates. You see my blue, negative 2, 3. That is coordinate A. 3, negative 3. That's coordinate B. All right, so from here we just solve. So minus 2 minus 3 makes negative 5. 3 minus minus 3 makes a plus, which would be 6. Continue. What is negative 5 squared? 25. And 6 squared is?
6.
Yeah, 36.
Yeah, because you didn't say nothing.
I just agreed, so sorry. I wrote it. What's 25 plus 36? 61. Can that be reduced in any way? No. So that means the length of this side is the square root of 61. So the whole point of finding the length of all of the sides was so that we could add all the sides. Okay, so let's do this. We're going to find the perimeter, which would equal all 3 sides added together. So let's add. We got 6 plus 5 plus the square root of 61. Let's pause. Will this as a square root help me? Will this written as a square root, will it help me find the answer? No. So here's where you are going to be allowed to hit that button on your calculator. Who has their calculator? You do? Most 4-function calculators have the square root button. You can only use it on a problem like this because you cannot just add 6 plus 5 plus the square root of 11. Or square root of 61, sorry. Yep. Yep. See it? So here's what I want you to do. The square root of 61, I want you to round to the hundredths. How many places is a hundredth? 2. So what do you get? So you hit 61 and then square root.
Oh. 61 square root.
There you go.
Whoa.
So 7.81. So whenever we're finding, when we're adding here, 6 plus 5 plus 7.81. We should be able to add these. What's 6 plus 5? 11. What's 11 plus 7.81? 18.81. That is the answer. Ta-da.
That was a lot.
Yeah,
It's
it
like,
was a
it's
lot.
18.
It is 18 backwards. This part is not a lot. I just, to explain it to you, it was. Finding the distance, that's what would take the longest. Yes?
So,
Go ahead, Justin.
So when it's not the A and C at the top, we just do like A and B. When it said final, we have to do the A, B, and C. When it's just A and B, we don't have to do all that. Like with C.
Find the perimeter of the object, you add all the sides. I know. I don't understand what you mean by C.
Like, okay, so you see a C in there, right? And if you take it out, you just do A and B.
A and B would be a straight line and not a shape.
Oh,
Do you see what I'm saying?
yeah.
The only reason we used A and B was because these were only the 2 sides that we needed to find the distance between. These you could technically use the distance formula on, but you would get 5 and 6. It's just easier to count. Yes, Jamari? Yes. That's more exact than rounding to tenths. All right. The next one, believe it or not, is actually easier. Here's a side note. Whenever you read this, this is, what shape is this? Triangle. And then you say ABC. Because guess what the points were? A, B, and C. Just so you know, I want you to know that. Number 3, or example 3, find the area of a triangle. Well, first off, let's talk about this. What's the area formula for a triangle?
A equals 1/2 B.
1/2 base times the height. All right, so we're going to do the same thing. Here's what I want you to know. Did that graph tell me the answer? No. Did that graph really have the answer on it at all? No. So guess what? The graph is only, so if you want to write this down, is only for like a visual help. It's only to help you see what you're doing. Does that make sense? Instead of it just being points that you're plotting or points that you're finding the distance between, it helps you see, hey, what shape am I dealing with? Well, can't I just look at this and say, decide what the measurement of it is? Okay? All right, so we're going to do the same thing we started with. We drew our x and y axis. We're going to plot our points. So 1 to 3. Positive 1 means we go to the right 1 and up 1, 2, 3. So that's D. E is 4, negative 3. So I go to the right 4, 1, 2, 3, 4, down 1, 2, 3. Here's my E. And then F is negative 4, negative 3. So negative 4, that means I go to the left. To the left. 1, 2, 3, 4. Down 1, 2, 3. All right, so what shape am I dealing with here? Triangle. So I'm going to connect my dots. So before you do anything, this one should be the simplest one you do. Okay? Because what 2 things do we need to find the area? Yeah, what's in the formula? We need the base, and we need the height. All right, so the base, what's like another word for base? the floor, the bottom. The bottom. So, what is the measure of this base? How many boxes wide is it? 1, 2, 3, 4, 5, 6, 7, 8. So the base is 8. The height is the only thing that you have to look at. Okay, so Tia, I did have a Tiana before. Look at the top of this triangle, or this triangle on the top of your page. It looks similar to the one that's on the board, yes? Mine is tilting to the right, yours tilts to the left, whatever. Where is the height written in this picture?
In the middle.
In the middle. Because guess what? When your doctor wants to find your height, what does he make you do? Stand straight up. Okay?
Yes.
Because the height is from the very bottom of something. What's the bottom of this object? The base. It's from the very bottom of the object to the very, very top of the object. Where is the highest point of this object? D. So how do we find the height from the bottom to the top? What do you think we can do?
Draw a line down.
We can draw a line and then, he said it, add. 1, 2, 3, 4, 5, 6. It is 6 boxes high. Ta-da!
Wow. So
Now we just, does it matter what order you multiply in?
No.
What's 1/2 of 8? 4 times 6 is 24.
Is that it?
That's it.
Hallelujah.
That's the answer. You didn't have to use the distance formula. All you needed to know was the base and the height. The base we counted. The height we We counted. All right, we have one more to do. It is a rectangle. The reason we have it, or it's a quadrilateral, we're about to graph it and you'll see that it is a rectangle. The reason we haven't done one is because they're actually easier than triangles. And I would rather do the harder ones with you than the easy ones. Okay? The harder ones get you prepared for when you're by yourself. All right, so what do we do first? Plot our points. We're actually going to find the perimeter and the area because it literally will take us 2 extra minutes. Not even. 30 extra seconds to find the perimeter. We're going to plot our points. -2, 3, which means we go to the left or the right. To the left, and then +3 means up. So this is, what letter are we doing? F. And then we have 1, 3, so to the right 1 and up 3. H is 1, -1. J is -2, -1. Ready? So what shape are we dealing with here? Because I have already said it. It's not slanted, actually.
A rectangle.
It's just a rectangle. Because you probably graphed a point wrong. I'll come look at it in a second. All right, so let's find the perimeter first. The perimeter, what do we have to do? Add all the sides. What's the measure of FJ? 4. What's the measure of FG? 3. GH? 4. JH? 3. So what we do is we add them. 4 plus 3 plus 4 plus 3, which equals 14. Because 4 and 3 make 7. 4 and 3 make 7. So boom, that's why we did the perimeter first, because it literally took us no extra time. To find the area, what is the area formula? That's triangle. Length times width. So what would the length be here? There's really no wrong answer. Sure, 4 can be our length. All right, then what would our width be? 3. So then we plug in. 4 times 3 is 12. Ta-da! Yeah. So here's what you're going to be doing. I have the answers, so I'm going to walk around and check. You're going to do the 4 problems on your classwork paper. What you don't finish, you will finish for homework. But I will walk around and assist you. Remember that graphing, this is for the end of my video. Graphing is just for visual understanding. Any diagonals you use to find the length, you use a distance formula. The perimeter, you need to find all of the side lengths. And the area, you need to find the length of what's needed for the formula.